Good morning. So we are proceeding with basic fundamental of engineering mechanics. So we are going to discuss today from the point of view of first unit. This one more topic of interest is type of forces on beam. So there are three kind of forces which normally we take into the consideration when we are giving questions to first year level. The first kind of force is concentrated force or point force. It is a kind of force which is shown here. It is acting at a particular point. 4 kilonewton is acting at a particular point. It is something like center of gravity, that is a concentrated force. The concept of center of gravity says that it is the resultant force of all the body which act at a place. So similarly, concentrated force is a force which acts at a point. It is also known as a point force. So it is acting at a particular point A. So point can be identified by a particular distance from either of the side. So you can take movement, that is the benefit of a point force. Second kind of force is UDL, uniformly distributed force, or UDL. Here this is a beam. This is a beam is given to you, which is supported here as a roller support, and here it is a hinge support. So there is a UDL. UDL can be shown like this, or it can be shown like this rectangular symbol. It can be from this is shown from upward. This is from top of the beam towards the lower side, or it can be from lower side towards the upward side, like buoyancy force on the in the on a particular beam which is in water, right? So it can be from upward to downward, or downward to upward. So this is normally it is shown like this. So the meaning of UDL is uniformly distributed force. If it is 4 meter and 2 kilonewton per meter, that means the total force is 4 multiplied by 2, that is 8 kilonewton. And every of the meter, you take 1 meter from initially, or from here, from there, from here, anywhere you take the 1 meter, it is going to be 2 kilonewton. So total force on 4 meter is 8 kilonewton. So this is basically the actual practical force, the kind of thing like the length of the beam or anything which is weight increases with the increase of length. So that's what it is. UDL is most commonly used kind of force. Now whenever we are knowing UDL, we have to convert it to concentrated force when we have to implement movement equation, because movement equation required force multiplied by the perpendicular distance if we are using scalar method, right? So now to do this, we have to take the center of this. So 4 meter means center is going to be at 2 meter, and complete force 8, 2 multiply by 4, 2 multiply, this 2 is multiplied by 4, 2 kilonewton per meter over 4 meter. So that will become 2 multiplied by 4 is the total force, and it is acting at the center of 4 meter, that is this complete is 4. So it is acting 2 from here and 2 from here. We have replaced roller with a vertical force and hinge with 2 unknown forces. So this is how we can simplify it to make the free body diagram and solve the question. Another kind of question, another kind of problem is where you can have is UVL, uniformly varying force. Uniformly varying force is the UDL, you are having constant force throughout the length, but here the amount of force is continuously increasing. At this point it is 0 kilonewton per meter, but it continuously increases, and here it is 6 kilonewton per meter, that is it is still increasing. So when we have to take the total force, we have to take the area of this triangle, that is average force is going to be 0 plus 6 by 2 multiplied by 3. So complete of the force is acting at the center of this triangle. Centroid of this triangle is going to be 2 by 3 of height from here and 1 by 3 from here. So that means this will be, if we have to take the center of this, it is going to be, this complete is 3 meter. So you take 2 by 3 of 3, show the force. What is the force? 1 upon 2, 6 multiplied by 3, that is 1 by 2, 0 plus 6 by multiplied by 3. So the distance from here is 2 by 3 of 3, and from this side it is 1 by 3 of 3. Replace the there is a hinge at A, HAVA, and at this VB. Okay, so this is there. These three kind of forces normally acts on the beam. Accordingly, we have to reduce to take the moment, because moment equation cannot be written without converting these kind of forces into concentrated force, because we need point of application. So let us see one more question, a typical example of this, where you are having trapezium kind of load. So it is, force is not starting from 0, it is from 2 kilonewton per meter to 4 kilonewton per meter UVL, uniformly varying load. So again there may be a hinge, we have replaced with 2, we have replaced with 1 for roller. Now we convert this into two forces what we know. One is UDL, one is UVL, starting from 0. So mind well, this 4 is divided into 2 and 2. So we'll have UDL of 2 over a length of 6 meter, and we have a UVL of 0 to 2 over a length of 6 meter. So we convert this into two forces. One force for UDL, that is 6 multiplied by 2, acting at the center, that is center of 6 meter. Second is that is UVL, we convert it into the force 1 upon 2, 2 multiplied by 6. Be careful, it is 2. It is the difference what we are taking from here to here. It is 2. We are not taking 4, we are taking 2. So 2 multiplied by 6, it is acting 2 by 3 from A point, 2 by 3 of 6, and 1 by 3 from B point. So this is going to be free body diagram. Then you can implement definitely the equation very simply. You can write summation Fx is equal to 0. Only one horizontal force is here, H is 0. Summation Fy is 0. Va plus Vb is upward, and downward force is 12 and 6. 12 is 6 multiplied by 2, 1 upon 2 multiplied by 2 by 6 is giving you 6. Then implement movement equation. I am taking anti-clockwise as positive. So VA and HA, we are taking movement about point A, this point. So in the movement of these two will be 0. 6 multiplied by 2 multiplied by 3, that is for UDL. So it is going to rotate. How it is going to rotate? It is going to rotate like this, about this point. So this direction is clockwise direction, this direction is clockwise direction. So we will take it as negative. So 12 multiplied by 3 negative, because I am taking anti-clockwise as positive and clockwise as negative. Then the other force is 1 upon 2 multiplied by 2 multiplied by 6, that is 6, and the distance is 4. So again how it will rotate? It will rotate like this. So again a clockwise, so again negative. Then VB will rotate like this. So this is going to be clockwise. Clockwise means anti-clockwise. Anti-clockwise means positive. So VB into 6. So we can use these three equations to solve the question. So similarly you can solve any question of reactions from the for the beams. Thank you. We may discuss some more questions as per the requirement.